8.4, composite figures. Please remember, composite means that we're going to have more than one figure or more than one shape. So we'll be looking at those today. More than one figure or more than one shape in some sort of figure, and we're going to compose those, put them together to find their total area. But before we can do that, I've got to review this guy. Now in your notes it looks just like mine if you're in classroom. This is a nice big blue line here because that's base, and this is another base. The area of a trapezoid involves taking the bases, base 1 and base 2, the two sides that are parallel to each other, and we add those. And then the distance between those, again on my slides, you'll see that that is in red because this height is in red. The distance between the two parallel sides, the bases, and we're going to take half, or as we usually like to write that, 0.5, and then we're going to just add the first base and the second base. That's all this means. B sub 1, base sub 1, and B sub 2, the second base, the second parallel side. And whatever we get there, take that times half, times h, and that's how we find the area of a trapezoid. So that's a quick review, but we're going to use that shape often today, again, to review it, as well as to review how to find the area of other shapes. Before we do that, though, your assignment today will have this, and some of them also, when we look at our NDSA or IXL, they might throw something like this on there as well, where it says find the area of the composite figure. So we could talk about how we see triangles and squares, but since it's here, what we're going to do is we're just going to count up our boxes. We're going to count up the boxes that are complete or whole boxes. So you can just put numbers in there too with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I like to count. So we've got 12 of those. Well, those are all the whole boxes. So I'm going to put that down here as a note. And then you and I need to add the others, these halves. Well, in class I would show us and remind us, but when you take a half a triangle plus another half a triangle, what do you get? Well, you get a whole triangle. So let's count up our halves. 1, 2, 3, 4, 5, 6, 7, 8. If we have 8 halves, how many whole triangles do we get? So let's take a look at that again. We had 8 of those triangles, and they were each a half. Half as a fraction's 1/2, or as a decimal it's 0.5. So when you take 8 times half, or you take 8 halves, that gets you 4. Half of 8 is 4. So when we add up all the whole spots, the whole boxes, that's 12 of them, when we add up all 8 of these halves, that gets us 16 full boxes, or in this case, we're going to call it units squared. So whether it's IXL or NDSA, or for us just today in our assignment, if it's something like this, count the full boxes, write that number down, and then count up how many half boxes there are, multiply that by that half, by that 4, and that gets you your 16 units. Go ahead and turn the page, and again, if you see the notes online, this is all in color. It's been hand-drawn, but this is a deck and a pool here. So it says find the area of a pool deck. This is a composite figure because you'll see it's made up of a few shapes. So there's a triangle. There's this rectangle with a circle or a semicircle in it too. So to find the area of this shape, we're going to break it apart into its shapes. So to find the area of this composite figure, we're going to break it into shapes. The first one, I'm going to start on the left and work with a triangle. So please, put down the word triangle, or like me, just abbreviate triangle. But we need to remind ourselves, the area of a triangle, I usually write it as BH over 2. You take your base times height and divide it by 2. Sometimes you might have seen it as half your base times height. Whichever one of these formulas you're used to, please write that one out. Because what we have to do to find the area of this triangle, we've got to take the base and the height. Now, our right angle is right here. That's our friend. That's a box. So in class, I'd have you say box. This box is what we're going to focus on. It touches this side, which is 10, and that side, which is 24. So 1 is our base, 1 is the height. Take 10 times 24, hit equals in your calculator, but then divide by 2, and the area of that triangle is 120. Circle that up. Because now we found the area of this triangle, which sometimes in class I will shade in or color on in. So then up next, we got this here rectangle. So then write out the word rectangle or just abbreviate it. And yes, I know it's annoying, but write out the formula. To find the area of a rectangle, you take the length times the width. So this is my cursive L times W. So you find the length. Again, this is where it's helpful to outline it in our notes. The length is 26, and the width of it is 26. Oh, I guess they're both the same size, so that's actually a square. So when you take 26 times 26, it gets you 676. Circle that on up, and then again, in class and on the notes, you're going to see that I shaded this in because now I've taken care of the area of the triangle and of this squarish or rectangle. Have I gotten all the shapes? And that's where we want to notice we got this guy over here yet still. So that is a semicircle. Well, how do you find the area of a full circle? That formula was pi r squared. But this is a semicircle. What's a semicircle again? Yeah, it's a half circle, so cut this in half. So now we need to take 3.14 times our radius. Now wait a second. The radius goes from the middle to the edge. Since this number here is in the middle, that gives us our diameter. So that is a 26. So we don't want to use 26. We need to cut that in half for our radius. So we need to take the radius squared. So 13 times 13. So now you type that into your calculator. 3.14 times 13 times 13. Hit equals. Don't write that down. Then divide by 2 because it's a semicircle. That gets us 265.33, 265 and 33 hundredths. Circle that on up. Let's go back to our figure. Have I gotten every shape, every individual shape in there? Yes, I have. So then down here, go ahead and put a plus sign between them. Or, of course, you're welcome to rewrite them if you so choose. My poor handwriting and efficiency, I'm just going to put the plus signs here. Add them on up. So, I've got 1061 and 33 hundredths. And now because this is area, it's feet squared. So you box that on up. All we're doing is we're going to find the area of a composite figure, the area of each shape. So, from there then, in class I might talk about what this looks like and so on and so forth, but it doesn't matter. What we're going to really look at is it's a composite figure. It's made up of a few different shapes. So you pick one and start with it. I see a trapezoid over here, so I'm going to work with that guy last because I like doing the easier ones first or the faster ones first. So I'm going to do this triangle. This triangle right here. Well, the triangle, I need the formula A equals base times height divided by 2. So write that on in. Now that 4 goes here, and then the height of this triangle is 5. So we're going to use 5 times the 4, divide that by 2. The base is 4, the height is 5. 5 times 4, hit equals, divide by 2, gets us 10. Circle it on up. Again, if you wanted to color it on in, we just found that area. Now this guy, it's a squarish rectangle. Sides are different, so it's technically a rectangle. So then find the area of that, and yes, I want you to put down length times width because I want us to remember that to find the area of a squarish rectangle, you just take the length, 9, times the width, 5. Gets us 45. Circle that guy on up, and then, okay, that's a trapezoid. You can spell out the whole word or just abbreviate it. This is where, again, you're welcome to flip back in your notes. We have that formula, B1 plus B2 H. But oftentimes we don't like fractions, so half as a decimal, top divided by the bottom is 0.5. And so what we're going to do then is we're going to add the base 1. We're looking for the parallel sides, the sides that will never, ever, 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 ever touch. So these sides here are never going to touch. So we need to take those as our bases, as 9 and 6.4. So 9 plus 6 4/10. And then we need to take that times our height, the distance between those two parallel sides. Those parallel bases, well, that's 5. So then you type that onto the calculator. It'd show us in class, but we got that 0.5, and then you can put the parenthesis right here. So you just type on in 0.5, then you hit the parenthesis key, so that way you can keep typing just like we have it here. 9 plus 6.4, then you hit this parenthesis key again, times, because again, remember, they're touching, they're timesing, 5. Type that on in, let the calculator do PEMDAS for you, otherwise you can do it yourself. In the parenthesis, you're going to add those, you get 15.4, so then you could just take 0.5 times 15.4 times a full 5, and that gets you the number 38.5. So again, circle that on up because we'll have to come back to it. Let's go check. So now I've done the triangle, I've done this rectangle, and I've done the trapezoid. So I've done every shape in this figure. So now it's just time to compose it together. Again, composite figure is composed or is made up of multiple figures. So you add them together, you get 93.5 inches squared. For our composite figures, that's all we're doing. Put them together. Put them together. What do you see? Last example here for us in these video notes. Find the area of the composite figure. There are two shapes. I got this bubble on top. It's a semicircle. And then this guy. Interesting. So you pick whichever one you want to start with. I'm going to start with this guy on the bottom because what we're looking at here is an interesting shape. It's not a rectangle because we got this slanted side over here. It's not a parallelogram. It's not a square. If we look, I got one side up here that's parallel to this side. So we got opposite sides parallel. That makes this one a trapezoid because not all the sides are parallel. So this guy's a trapezoid. So let's do it again. Trapezoid. Ugh. Yep, that's that weird formula. If you want to put down 0.5 right away, you can. But that's, again, where we take base 1 plus base 2. The two sides, the two bases that are parallel, you add them and take that times the height. So off we go. 0.5 times, again, now in class and on the PDF notes, you're going to see that I have this in blue and this in blue, because those are our parallel bases. So I got to take 4 plus 6, and we're going to take that times the height, the distance between them. You can type that into the calculator, or you can do PEMDAS yourself. 4 plus 6 is 10, so half times 10 times 2, well, that gets us our 10. And so from there then, we just continue on. And the next shape then is this bubble. That's not a bubble, it's a semicircle. Go ahead and put down semicircle. And now that we've got that, again, write down the formula for the area of a circle. A equals pi r squared. But do we have a full circle? No, it's a semicircle. That's why we wrote that down. Since it's a semicircle, that means it's half a circle. So take the formula and cut it in half. You and I need 3.14 times the radius. So we want the radius of this circle. Since that 4 is in the middle, that means it's our diameter. So take 4 divided by 2, cut it in half. That gets us our radius. That's the number we need to plug in here. 2 squared. 2 squared, well, that's just putting down 2 twice. So then you're going to grab your calculator. You're going to take 3.14. You're going to take it times 2 times 2. You're going to hit equals. Don't write down that number. Divide that by 2. And then write down that number. So again, if you got that 12 number, I like that. But don't forget, it's a semicircle. Cut it in half. Let's take a look. I did the semicircle. And I did the trapezoid. So I have done all the shapes in this composite figure. It's now time to compose their areas. 16 2800 meters squared. That is what we are looking at for areas of composite figures. So again, to find the area of any composite figure, break it into its shapes, find the area of each shape. Circles, we had a whole unit on that. Trapezoids, that's why we're doing this lesson, because I want us to review this formula. This we learned, but we just don't retain, we don't remember. It's just common, so we want to review that. Otherwise, we're familiar with rectangles and circles. We've done those. And another refresher on triangles, which we're going to be using in our surface area unit with both rectangles, and squares, and triangles.